The last video was about this engine. The aim was to build a one-valve cylinder head with rotary valve. The principle is simple. A rotary valve with only one continuous opening slot controls the inlet and outlet at the same time. As this only needs 180 degrees for 4 cycles, the rotary valve rotates at a ratio of 1:4 to the crankshaft. Here you can see what it looked like in the finished cylinder head. I think you can see the function and the principle very well. But the performance measurement brought sobering results. An output of 0.23 horsepower from a displacement of 6.5 cubic centimeters was a disappointment. My current design of a rotary valve cylinder head with 2 valves produces 0.6 horsepower. To put it simply, much more powerful. What we do now? Should I give up? Of course not. I had an idea for a new one-valve cylinder head with rotary valve. Let's take a look at that today. Here it is. Here you can see a cross-section of the new one-valve cylinder head with rotary valve from the CAD. I would now like to explain how it works. Here is the timing belt pulley. Here is the inlet where the carburetor is then screwed on. Here is the outlet. This is the rotary valve. Here is my hemispherical combustion chamber with double glow plug. The rotary valve is in the intake stroke here. The fresh gas enters the combustion chamber with virtually no obstructions. My aim was to make the design as flow-optimized as possible. I designed the same principle for the outlet. The exhaust gas can flow out through the outlet almost unhindered. Let's take a closer look at the combustion chamber. The rotary valve is centrally arranged. The valve position in the picture is at top dead center of the piston, means in the change from exhaust to intake stroke. You can see the exhaust valve closing and the inlet valve opening. This is the exhaust opening in the rotary valve, and this here, the inlet opening. To make this easier to understand, let's fast forward and look at the function directly in the finished cylinder head. Here you can see the one-valve technology quite clearly in the overlapping valves. Here you can see that the gas simply can pass straight through the head. This is the top side with the 2 connections for the carburetor and the exhaust. So why all the effort? What is the benefit compared to the previous cylinder head? In my previous design, the inlet and outlet shared the same valve opening in the rotary valve. This isn't a good solution, as the outflowing gas blocks the incoming fresh gas. So a proper gas exchange isn't possible. The new design solves this problem as the inlet and outlet are separated from each other, but they still share the valve opening in the cylinder head. It's still a one-valve design. I then started to manufacture the cylinder head. A few details about the cylinder head. This is made from ENAC 47000. This is an aluminum alloy with 12% silicon in it. This alloy has very good sliding properties and is also wear resistant. The rotary valve will also run directly on this aluminum without a cast iron sleeve I had in past. I'm often asked how I manufacture my parts. I have simple equipment at home. A cylinder head like this requires a lot of fixtures, operations, and especially time. The cylinder head, for example, took me around 12 hours to make. Now let's move on to the rotary valve. I have made two versions, one made out of bronze and one made out of cast iron. The ones in the picture are still the blanks. The material makes no difference in production. It's all about the sliding properties and thermal expansion. Since the rotary valve heats up more than the cylinder head, you have to be careful that it doesn't expand too much during operation and then block. As the selected bronze alloy has a similar thermal coefficient of expansion as the aluminum of the cylinder head, I decided to use cast iron. This fits with the thermal expansion, and the sliding properties of this material pairing are also very good. The rotary valve is ground and the cylinder head is honed, a tried and tested combination. The clearance of the rotary valve is 5 micrometers on the intake side and 10 micrometers on the exhaust side. As the rotary valve heats up more on the exhaust side, the bore in the cylinder head is therefore slightly conical to compensate that. Here are a few words about how I hone. I use a honing attachment for the lathe with diamond honing reamer. The honing attachment can be adjusted in 0.5 micrometer steps. The manufacturer of this tool is Pimamo. For every nominal diameter, a different reamer is required. The exhaust and the intake manifold are 3D printed from aluminum. That's pretty much it. This is what the engine looks like when assembled. You can see it runs and the throttle response is also good, but that doesn't say much. We now need to measure the performance. To do this, we mount my well-known high inertia flywheel and record the speed-up curve. We achieved 0.28 horsepower at 13,200 RPM and 0.16 Newton meters at 9,600 RPM. The maximum speed was 17,600 RPM. Compared to the old one-valve design, we were able to increase the power by 22%, the torque by 7%, and the speed by 14%. To be honest, this is still a bad result. My rotary valve head with two separate valves and the same timing achieves 0.60 horsepower, which is much more than this one here. So what is my conclusion? One-valve cylinder heads aren't a good solution to get a high power output. They may be suitable for engines with low revs, but not for high revving engines like mine. Personally, I will not deal with this topic any further. I hope you enjoyed the video. It's always a lot of work, so please like and share my video and subscribe to my channel. Thank you.